Now let's see how we can create our own custom particle forces. And in here, right now we are using this pop curve incompressible to make or this particle move along or this line. And in here we have this pop curve force. And if I let me find this, and here we have it. And both of these forces, while do have their uses, they are not actually working properly. They're not actually following our line accurately. And to fix this, you can create your own forces. And to actually create them, we are going to use the volumes for that. Let's see how we can do that. First, I'm going to just remove this pop curve force and also this incompressible force. And let's go back onto the SOP level. And in here we are going to build a volume and velocity volume, and we will going to be import this velocity volume back into our this DOP net and make these particles to follow our this velocity volume. So let's go into the geometry level in here, and in here I'm going to just create a simple box in here. First, let's add a box at the origin, and I'm going to just make its uniform scale a bit bigger. And maybe let's go into the circle node and let's play around with its center and maybe zero this out so that we have our circle inside of this box. And I'm going to make this size even more bigger. I think that value is good. And let me view the geometry. Okay, here we have our box geometry, and now we need to convert this into volume. And you know that there are several ways we can convert this into volume. First, we can add a VDB from polygon node, and if I were to create this and connect this, and it will create our this surface or fog VDB, and it will be sparse, which means that all of these values on the inside of our box, if we zoom in into the inside, keep zooming in, and here as you can see in the inside we have this hollow, this box geometry, which means that our this VDB from polygons node will going to be hollow as well, and we are discarding the all of these values on the inside. But I want to fill this box with the velocity vectors, and to actually make them fill, I'm going to use a pyro source node. And in here onto the pyro source, you know that we can fill our box with particles. So let's go into the pyro source, and onto the mode I'm going to say volume scatter, and it will fill our particles, fill our box with particles. And right now we are dealing with a lot more particles. I'm going to just increase the particle separation to lower down the number of particles. We do not need that many particles. And now let's convert these particles into volume. And right now we are just dealing with particles. We only have these points. And to actually convert them into volume, first we need the attribute that we are going to rasterize them. And in here attributes are 0. We do not have any attribute. So let's add this. And in here we can type our own name. I'm going to just pick this velocity, and it will just create a V attribute if I were to middle mouse button. And here as you can see we have the V, and its value is going to be 1 by 1 on all axes because of this default, which is fine. And now let's convert our this velocity attribute into volume, and we can do that by using the volume rasterize attributes node. Sorry, not this one, volume rasterize attribute. Let me add this and connect this in here, and in here I'm going to just pick up my V attribute. And in here we have this box filled with this fog type visualization, and we have this velocity volume, and its value is 1 by 1 in all axes. And what I like to do, I like to fill these velocity volume with noise. I want to create my noised up velocities, And to actually add the noise, we have a node called volume noise. Let's add a volume noise, and in here we have the volume noise fog if we are dealing with a floating point fog volume, or if we are want to add the noise onto STF volume. But V is a vector, it is a velocity, it has 3 components. So let's use the volume noise vector node. Let's add this and connect this in here, and let me bring up its parameter. And here as you can see, we have the same noise option in here, but by using this volume noise vector, we are adding our velocity onto volume name V, and we are using this noise to actually add a noise in here. And I can actually visualize my velocity vectors. Right now we are visualizing this as a fog, and to actually visualize your velocity, fog type visualization is usually not the better option, because we do not know how are these velocities actually look like. And to actually visualize the velocities, we have a node called volume trail node. Let's add a volume trail node, and it has 2 inputs. It needs the points to trail and the velocity volume, and we know that that is our velocity volume V. Let's connect this, and now we just need the points. And for the points, I'm going to use these points, and what it will do, it will use these points, all of these points, and make these points move along the velocity and create a line. And it would be better if I just show you. So let's connect this in here, points to trail. And now if we visualize the volume trail node, and here as you can see, this volume trail node is actually trailing these points. It's moving these points along the velocities and drawing a line, which means that now we can better visualize how our velocities look like. And into the velocity volume, I can play around with the amplitude, and here as you can see, I am creating a noised up velocities. And right now I think we are dealing with more points. I'm going to just increase the particle separation to create less of these points to have faster feedback. Let's go into the volume vector, and in here we can adjust the amplitude. I can play around with the element size, and right now the operation onto the noise is set to add, which means that we are taking the values, velocity values, which are the one in all of the axes, and we are adding the noise. And right now these velocity vectors are not looking good because we are adding them. But what I would like to do, I would like to fill this entire volume with noised up velocities, and to actually do that onto the volume noise vector, I'm not going to just add this, I'm going to say set. And by using this set, we are using this noise to create the velocity volumes. And in here, now I can play around with the element size, and now we are just completely discarding these values 1, and we are using this volume noise vector to add a velocities. And in here I have different types of noises. I can change this to alligator noise, and I can maybe let's change this to whirling noise, and let's change this to fast noise. And we have all of these different types of noises. And let's go into the volume trail node, and in here we can adjust the visualization. I can play around with the trailing length to control the length of our these points trails, and it is just for the visualization purpose. It will visualize these velocity volumes. And now that we have this V, we have these velocities, and here as you can see, right now we are visualizing this as a fog, and it is not a good visualization because we do not know how these velocities are actually look like, and that is why we need the volume trail node. And now let's import these custom velocities that we have just created into DOPS. and I'm going to connect this into this third input. And now let's go into the .NET node, and in here to actually import these custom forces, we have a node called pop at vect by volume. Let's add a pop at vect, and here we have the pop at vect by volume because we want to use our volume velocities. So let's add this and connect this in between. And in here right now we have the velocity source. It says SOP, which means I can choose the location, or I can just say please use the third context. And in here it is looking for a volume that is named val. But if we go back, and in here as you can see we have a VDB, vector VDB. Sorry, it's saying density. We need to refresh this, and here as you can see we have this one VDB volume. We have its name is set to V. It is a vector, which means we need to go into this dynamics, and in here we need to change this name. And in here I'm going to just type V, which means that V is the velocity volume that I want to import. And if I were to hit play, and here as you can see we have these particles moving, and I'm going to remove this pop wind node to actually make my point that we are completely using the velocities that are actually coming from our SOPs. And here as you can see, if I were to view this volume trail node, or maybe let's template out these volume trails, and there you will see that our particles will follow the path of the noise stub path. And here as you can see, and that way you can create your own custom forces. Now let's see how we can use the pop at vect by volume to make our particles follow the path of this line that we have created in here. And let's see how we can convert this line into volume and import this in here to make these particles follow the path. And we will do that in the next lesson.